All right, hey guys, back here again. Today I wanted to go over another topic, which is shapes, UI gesture recognizers, and Bezier paths, and how you can manipulate objects on a screen with different gestures. Because in iOS, there's an incredibly powerful gesture recognizer engine built into your actual iPhone or iPad. And even in Mac OS X with the touchpad, and being able to tap into some of these APIs, frameworks, and classes that Apple offers can really make apps really powerful. So today we're going to create a simple application. Basically, what it's going to do is we'll create a shape class, which will allow us to draw a shape with a Bezier path, fill it, rotate the shape on the screen, and move the shape dynamically to any point on the screen. All right. So let's get started. We'll open up Xcode as always. We'll create a new project. We'll just single view application. Call this shapes. Call it shape gesture or just shapes, I guess. Swift is fine. Everything else here is completely fine. Put it in its default location. Again, we're going to do everything pragmatically, so no use of this storyboard. We're not going to use it. You can delete it if you'd like. I'll leave it for now. So I'm just going to clean up the project, delete the view did memory, the did receive memory warning, sorry. And let's go ahead and get started. So the first thing I think we should probably do is create a class. It's going to be called a shape. It's going to be inherited from a UI view because our shape is of a view. And as soon as we do that, we want to specify the size of all of our shapes. So we'll just say let size be a CG float, not fonts, like that. And we'll just let's just assign it 150 for now. I think that's a pretty good size. The next thing, let's create an initialization or init method. So we'll do a custom init sort of. We'll just say init, and we're gonna specify a position that we want to put this shape in for when we initialize it, and we'll say origin. And we'll use a CG point for this. Remember, guys, a CG point is basically the coordinates of where you want something to be on the screen. And in our init method, we need to call something called super.init. Oops, super.init. And we're going to call the super initializer with the actual frame. And what we'll do is we'll actually create the frame in here. So we'll do CG rect, and we'll say the one with this CG float, and we'll just position it at coordinates 0, 0. And we want to position it and create this the frame of this actual shape to the size that we defined above. So we'll just say size, and the height, we'll just make it the size as well. Okay, and we want to actually tell it where we want it. We want to position it somewhere in our view. So we will do that by just calling self.center, which gives us our center CG point, and we'll assign it to our origin that we are passing in with the initializer. Okay, and what's going to happen here is because we're inheriting from a view, Swift forces us to use this required init coder a decoder method. It's just required oftentimes when you're creating a custom initializer, when you're modifying an object, when you're inheriting. So in this instance, we'll go ahead and do that. Okay. All right. So now what we can do is we can actually go up here into our view did load for our view controller, and we can add a shape object to the view. And the way we'll do that is we'll say, we'll just call this, let shape view be of type shape. And we'll use our initializer we created right here just below for our shape class. It's going to want a point. And we're going to say, let's just put it the views.center for now. So that's basically going to render this shape in the center view of the view controller. I think that's a good spot to start placing our shape. Let's add it into our subview with self.view.add subview, because we have to add in this shape, otherwise our view controller doesn't know where to place it in the hierarchy. Okay, that's looking pretty good. All right, let's go ahead and run this in our simulator and see what we get. And we get absolutely nothing. And that's perfect because that's exactly what we want. And the reason we're getting nothing is because we haven't defined any properties on our shape. What we could do, for example, is for this, because we are creating a shape, so we're going to use something called a draw function. And the way that we're going to do that is there is a method that is on a view property that we're going to call on our shape that will actually draw around the edges of a rectangle, a CG rect. Because remember that UI views um, all are technically a rectangle until else otherwise defined. So what I mean by that is that when we create a view, we always specify what? An origin, which is the X and Y, for example. If we look at this in it up that we have up here, we're creating this rect. Remember, CG, core graphics, rectangle, X, Y. This is where we want it. This is the size of the width and the height. And width and height is always a square. So if we were to basically draw this out on the screen with a background color, we'd see basically a perfect square because we're doing 150 for the width and 150 for the height. Now, going back to what I was saying, there's a draw function on these views. Draw basically will draw around the edges if we want. We can draw around any coordinates almost that we want to decide to use. So what we're going to do is simply we're going to override a function called draw. And we can see draw in rect right here. And so what we want to do here is we need to create something called a path. And this path is a UI Bezier path. And a Bezier path, we can see, is a class that lets you define a path consisting of a straight or curved line segments and render that path in your custom views. Because we're creating a custom view, this is what we want. It will allow us to draw around it. And we want to use a rounded rect. So it's going to give us somewhat of more a oval around the rectangle. It's not going to be a square perfect line. If we wanted to do that, we could use another method. For this example, we're just going to use this one. And what we want to do is pass in the rect, which is, it comes basically from our method draw right here. And that's the basically the CG rect of the object, the view that we're using. So whatever the width and height is, basically is going to get passed into this rect, passed into this rounded rect. And that's going to ask us what we want for corner radius. That's just going to clip the sides of each corner of that square or that view. So we'll just say 10 for now because that's pretty good. And then I would say what we want to do is we want to give it a color. So we'll do UI color. We'll just say red, for example, and we'll say set fill. And set fill is a function on UI color that will actually fill in the interior of this, what it draws around. So we can use whatever color we wanted there, for example, or however we want. And then we're going to say path.fill. And what that does is that actually takes the color, takes the fill. Basically, if you're to take a crayon and draw a line around an object, and then you're like, I want to fill it in, that's what that does, filling in. Okay, and so the next thing we want to do is, because we're going to have a clipped edge for the actual path that's being drawn and colored in our red circle, almost oval shape, we want to actually specify something called a line width. And I'm going to use this variable just simply and set this equal to, I'll just give it a CG float value of 3. And essentially what this is going to do is we're going to specify path.line width, and this is almost a border that's going to go around the outer edge. So we'll say self.line width. So that's just going to set that basically equal to 3. And then we'll use UI color because we want to set a color on that that line width. And we'll just say set stroke. And set stroke is the method that basically is setting the stroke to a certain color. And so then we'll just do path.stroke, which is a function that sets the stroke actually on the object. Okay. And so if we run this now, we're going to have our object. Now we haven't modified or added any gestures into the object yet, but we're going to do that in just a second. Let this load back up. we should see a red rect with kind of like a black border around it. You can almost see like that. Perfect. So that sets the stroke around the outer path like this. Now, if we click it, move it, do any like gestures, nothing's happening, right? Okay, so let's add in gestures. So the way we're going to do that is let's have a function that says add gestures, yes, it's here. And it's going to complain for a second because we don't actually have a function that does that. And so I'll put that down here. Okay, and what we want to do is we want to add our gestures into this object. So gestures, the way that they work is gestures can be added anywhere. They can be added into this background view, for example. You know, if I scroll, if I pinch, if I zoom, they can be added into an object as well. So for this example, we're going to add these gestures into the object because we want the object to be able to, we want to manipulate this object. So we'll say, let's add, I would say, a pan gesture, I think would be really cool. So we can move it around, and a rotation gesture. So let's just say pan. And we'll just do pan gr for gesture recognizer equals UI pan gesture recognizer. And there's a initializer on this with a target and a selector. Our target is ourself, right? Because we want to enact the gesture on ourself. And a selector is going to be a method that we will basically perform once this gesture is actually happens. So let's give this a method name called handle pan, I guess. That's a good name, right? And it's going to complain for a second. But what we want to do then is now we want to add the gesture into the object. And we do that by very similar just to like self.add subview, but we do add gesture here instead. Recognizer, and then we're going to add the pan gr. Okay. And so we'll create a function so this stops complaining to us. Handle pan, I think I called it. Right. Okay. That will go away. And let's do the same thing. Let's just copy it, and let's do one for rotate. And we'll call this rotate gr, gesture recognizer, and we'll add that there, and we'll say handle rotate, and we'll create a function so it stops complaining as well. Handle, oops. Okay, pretty good. So in our initializer, each time this object is created and as many times we're going to use it, we're going to add in this gestures or these gestures that are defined in this function. So this just makes it a little bit cleaner, a little bit easier to use. So let's work on our pan gesture function. So we want it to do something. First thing we want to do is we want to tell it, okay, hey, we're going to pass in a gesture. So we'll just say pan gr for gesture recognizer, and this will be a UI type, UI pan gesture recognizer, okay? And so what we're going to do in this function is we need to basically make sure that we have hold of the view that we're going to use. So we're going to say self.superview dot bring subview to front of self. So that basically ensures that we have a handle on our self. Okay, so then we want to create something called a translation. And we're going to set this equal to our pan gr's translation in view. And we'll assign this to ourself. And if we look at this, basically what this does, or this function does, is it returns a CG point of the translation to the coordinate systems of the specified view. So basically what it does is it says it calculates out, okay, this is where you pretty much move to view. So next, we want to basically assign the object we're using, the center X and the center Y, to the translation that updated CG points X and Y. So we'll just do that simply by calling self.centerX, self.centerY, plus equal the translations, because it's a point, remember, dot y. Okay. And the last thing we need to do is we need to get a handle and call, there's a method called setTranslation right here to a point. Now we don't want to set it to anything right now because this actually takes it. So we could technically just specify the translation in here, but to make it clear, I just wrote them out for you guys and we'll just say self in here. Okay. And so let's run this and see. We should be able to hopefully pan at this point. We can pan. So I can move this thing anywhere I want, you know, any corner, any view, any point. Oops. This can be completely moved. So that's panning, that's moving something around the screen. Okay, let's get a handle and get this this rotation in. So the way that we're gonna actually do that is we're gonna do something very similar. We're gonna call this same thing, we need to get a handle of the object, so self dot super view, and we need to instantiate it with a bang to basically force it out because we know that we have a super view in this situation. Bring to front, oops, capital locks, don't come on, okay. So basically now that we've got a handle on our view, we can now create something called a rotation, okay? And the rotation is simply going to be the name of our gesture, which the gesture rotation gr. And there's a property on this which is called rotation, which is a CG point that's tracked as well when the gesture is moved, and I'll show you that right now. Rotation in radians, which will return basically a CG float, which is very nice. So now we can do the same thing. Self.transform equal to self, oops, dot transform dot rotated by, and we want to specify what it's rotated by. Well, we know it's that rotation, right? And then we can call something called rotation gr dot rotation equal to 0. And the reason I'm putting this at 0, it might seem a little confusing right now, is simply just because we don't want to move after we've already set the transform. So we're doing self.transform, right? Which transform, if you don't know what transform is, it's just basically something that iterates from something called a CG affine transform, and that stands for core graphics affine transform. What's really cool about this class is there's actually a lot of different core graphics transformations that can be applied for animations. Core graphics and core animation are kind of the heart of all animation in iOS. So yeah, that's what that is. So we're just basically saying, okay, we're gonna set it equal our transformation of our object to whatever we want, whatever is actually rotated by the user. And that's that rotation that's tracked by the gesture. So let's run this, see what we get. So we can still move it, and we should be able to, if I'm just holding down the Option key on the keyboard, you can see I get these little arrows, or these little dots. And if I click and then I hold down the Option key as I'm holding and move the mouse, you can see I can now rotate the objects any which way I want. Sometimes using these you can see are harder. I can't do the outside view, but I can do, if I click on this view and then I hold down Option, I can rotate it. So that's it, there you have it. We discussed drawing Bezier paths on shapes, which are views. We discussed gesture recognizers, pan and rotation. There's also something called pinch, which you can use to scale the size of an object, which is very neat. Maybe we'll cover that in a later video. And again, if you guys have any questions or if you guys need a copy of the code, I'll try to put this up on GitHub for you guys. But if you guys have any requests or any, like I said, questions, please let me know. All right.